Меня интересуют только научные исследования.
Зил завелся. Четко работает, не троит. Сейчас мы посмотрим на двигатель. Что там за двигатель? Вот так, сейчас, секунду. Сука, капот запаян. Это секретная военная разработка. О, двигатель, живой двигатель.
Amero Engineering is an additive manufacturing solution provider using selective laser melting and direct laser deposition. Leveraging our partnership with Monash University, we have access to the cutting-edge technology and the leading research in additive manufacturing. The objective of this project was to create a technology demonstrator that would showcase Amero's expertise. With the majority of our commercial projects being too sensitive to share, we wanted to build something that would really appeal to the public eye. Having already shown our capability in the past, we're looking at what could be the next challenge: building and validating an additively manufactured rocket engine. Building a rocket engine not only showed Amero's capability, but demonstrated the calibre of our local engineers. We worked alongside the team to develop an engine that would really show the benefits of additive manufacturing. The final design was an aerospike rocket engine with a unique multi-chamber design.
Well, basically the team went away and essentially worked together, looking at the basic rocket equations, looking at how large does a rocket need to be in terms of how much thrust it actually produces. An aerospike nozzle engine is special that it's also an altitude compensating rocket nozzle, and that means that it can be most efficient at any altitude compared to a conventional rocket nozzle design, which is only suited or designed to one particular altitude. We've also designed in multiple combustion chambers into the engine, and these fins which divide the combustion chambers not only hold the spike but also allow us to investigate thrust vectoring potentially in the future.
A project that exemplifies the benefits of working with Amero in conjunction with Monash University is the aerospike rocket motor project that we've just completed. What's happened with this project is a collaboration between Monash University and Amero took advantage of what additive manufacturing could do in terms of enabling a one-piece rocket design. It's an example of something that could only be additively manufactured and something that is beneficial in terms of the performance outcomes of the design. Additive manufacturing can reduce the project delivery time because we can generate prototypes and we can generate production just within a few days of receiving the design file.
In order to design a rocket engine in such a short period of time, we had to basically discretize the rocket building process. This involved splitting up the design problems into small codes that each member of the team could write, and then we wrote a larger framework which allowed us to tie all those particular codes back together. This allowed us to use a really iterative approach in designing this rocket in a very short amount of time. From the success that we've had in this project, we're really looking to take the strengths forward. That have been, of course, the additive manufacturing component, but along with our expertise in fluid mechanics, we're looking at developing flight scalable engines of the future, which may include thrust vectoring, the additive manufacturing process, and potentially another aerospike nozzle.
Студия «Союз» прощается с вами. А альбомы всех исполнителей, представленных на этом сборнике, вы можете всегда приобрести в фирменных магазинах студии «Союз». До встречи!